huomenta kaikille. Äskeinen video johdatti meidät tämän tilaisuuden hyvin ajankohtaiseen teemaan, ilmastonmuutokseen. Kaikki 3 oppilaat tekivät muutama viikko sitten LVIRO-tunneilla ilmastonmuutokseen liittyviä kysymyksiä.
Today, our questions will be answered by a real expert, group leader Antti Mäkelä from the Finnish Meteorological Institute. Welcome, Mr. Mäkelä.
Tervetuloa minunkin puolestani.
The stage is yours, Antti Mäkelä.
Thank you, and I'm really glad to be here, and thanks for the invitation. And so my name is Antti Mäkelä. I'm a research scientist at the Finnish Meteorological Institute. I've been working there since 2001, and I'm a meteorologist in profession. I have a doctor's degree or a PhD in meteorology from the University of Helsinki. And during the past almost 10 years, I have been leading a group, which is the group name is Climate Change and Extreme Weather. And we are dealing, my group is dealing quite a lot of the topics that you have also discussed within your class. And so I received beforehand a lot of questions from different grades, so thank you for those, and really interesting and relevant questions, which I partly, or some of those, I will also try to answer the best I can today. But let's go to the topic. So first of all, I'm not sure, because when I have been in the elementary school and in the high school, climate change was not discussed much at that time in the courses. And I'm not sure what is the status of today, so how much and in what level you have been discussing and learning about climate and weather in general, and climate, and then climate change. But first I will show a really simple, I would say that even in the first grade students, this kind of like a picture could be given and shown. So here you can see our lovely planet Earth, which is tilted. Its rotation axis is a bit tilted towards the sun, and that's quite important because that governs how much in different latitudes, in different regions from south to north, the Earth is receiving solar radiation, so the warmth from the sun. And sun is actually the star that is actually giving all the warmth and all the radiation to our planet, and that is the key thing to remember. And then, because the planet Earth is like tilted, like I mentioned, that means that we have a seasonality, first of all, and for example, now in the northern latitudes, it's or a few days ago, yesterday actually, it was the darkest time of the year because the sun is at the southernmost point in the southern hemisphere, and the northern latitudes are receiving the less radiation it ever receives during the year. And then also the Earth is rotating or going around the sun, which then gives us the seasons. And one important thing, what also governs the conditions, like the climate conditions in our planet, is the atmosphere. So our planet Earth has a unique atmosphere, and it consists of gases and particles and various kinds of things. But how much of these different things and gases and aerosols are in the atmosphere also play a role in the how warm or how cold this planet is. So that is the simple picture of what is actually the main sources of the climate conditions that we observe and have always observed during this since the since the Earth has been around. And now, also in your questions, there was a question about this. So how can we, scientists, for example, how can we forecast climate, for example, 100 years ahead, if we cannot forecast weather 1 week ahead accurately? And that is a very relevant question, and before answering that question, it's important to know what actually is the difference between weather and climate. So, and when I have been, for example, giving this kind of lectures in schools or even in ministries, it's surprising that it's not surprising, but it becomes clear that there is a misunderstanding quite often between these two. So what we easily mix the climate with weather and weather with climate. And so weather is something that, for example, we could go now to the schoolyard of your school and, for example, measure the temperature, wind, relative humidity, or whatever atmospheric variables in a certain time, and that is the weather. So it is fixed on a certain time, in a certain location, and weather forecast is trying to forecast those conditions hour ahead, day ahead, week ahead, and so on. But climate is something that you cannot actually measure in one specific location in specific time. It is something that is calculated from the weather observations. For example, if there would be a weather observation station in your schoolyard, and there would be observations from several years or several tens of years, we could then calculate the climate statistics, the climate of your schoolyard from those weather observations. So we would get these kind of like distributions. For example, what is the temperature on average during, for example, today at 3 p.m. in your schoolyard, and then we could compare the weather of today to that climate statistic, whether it's now colder than average or warmer than average or windier than average or whatever. So climate is this kind of like a longer, slowly moving statistics of the weather. And now, when we are talking about or thinking about the climate change, it's important to understand that we are talking about the slowly shifts in the climate. So long-term movements of the weather conditions in general. So here is actually, this was a very good question, so how it's possible to make a forecast for, at the end of this century, for example, to Finland, when it's difficult to make a forecast for a few days ahead. And when we are doing like a weather forecast, for example, at the Finnish Meteorological Institute, we are focusing on the observations. So what is the state, the condition of atmosphere today at a certain moment? And then, because we know that atmosphere is actually fluid, and therefore it follows the equations of the physics and dynamics. That means that it can be actually calculated mathematically with the quite challenging formulas, challenging physical equations, that okay, if we notice the conditions of the atmosphere today and now at this moment, then according to these equations, what is the probability that the weather is something, for example, hour ahead or day ahead or something like that. But as you might know, there are quite a lot of challenges. First of all, the physical or dynamical equations that we are trying to solve are impossible to solve actually, at least with the present computer, even though the computer power has increased quite substantially during the past years. Still, we have to make estimations on those formulas, and that means that there is always some small error. And then the other fact that is giving us uncertainty is the point that we cannot ever actually measure all the points, for example, in this classroom, all centimeter to centimeter observations of the temperature, humidity and so on, which then also gives some small error. And these small errors then actually get greater when we are making a forecast in time, and that means that at some point the forecast is getting too wrong, or too uncertain, that it's not basically useful anymore. But when we are predicting how the climate changes, we are actually focusing on understanding how the elements in the first graph I showed, where it was the sun and the earth and the atmosphere, so how these conditions actually change. And if they change, what is the reaction of the Earth's climate to those changes? So it's totally different problem than forecasting weather. And the role of the atmosphere is actually quite substantial and has always been when this planet has had an atmosphere, because you might have learned that this atmosphere actually is giving this kind of like greenhouse gas effect to the planet Earth. So without the atmosphere, our planet would be much colder than with the atmosphere, and therefore actually the greenhouse gas effect, we can say that it's actually really valuable to our planet, because this planet has evolved and the biodiversity is really unique, and we don't know any other planet that has these kind of conditions. But now, if for some reason this greenhouse gas effect either weakens or gets stronger, that also, of course, then has some kind of impacts to for example, to the biodiversity or the climatic conditions in the planet. And now, one question that is maybe the most often asked from for example, me, is that we know that the climate has changed during the lifetime of our planet, like during hundreds of millions of years. We know that there has been quite substantial climatic changes in the planet. So what is why to fuss about this climate warming, what is happening now? Well, I can say that this is something unique which has never happened before in the lifetime of our planet. So meaning that one species in this planet is actually making this whole warming happening, and this has never happened before. So previously the climate changes have been related to, for example, the solar, so sun has certain cycles in its radiation activity, which are in cycles of hundreds of years and thousands of years and hundreds of thousands of years. Then also, for example, if in the past there have been really, let's say, heavy volcano eruptions, they have cooled down the Earth, because these kind of like particles in the atmosphere, they reduce the solar radiation coming to the Earth, and that actually makes the Earth's climate cool quite rapidly. But now we are in a mid of this kind of situation that human species have actually taken carbon, like fossil fuels from the below the surface of the Earth, and that carbon has been actually not involved in the normal carbon cycle of this planet for millions of years. And now, during, let's say, 100 years, actually, we humans have taken it from there and burned it to the atmosphere. And based on a really simple principles, scientists almost 100 years ago, they make an assumption that, okay, we are now burning a lot of fossil fuels, and carbon dioxide there's more and more carbon dioxide in the atmosphere, so that should actually at some point start to make this planet warmer. And now it is actually a fact. So it is a fact that the concentration of carbon dioxide have increased substantially in the atmosphere, and it should make this planet warmer, and now based on even observations it is a fact that this has happened. And this graph shows quite clearly what I am talking about. So here in the graph you can see the carbon dioxide concentrations in the Earth's atmosphere in 800,000 year period. So in the x-axis, in the left side there is the carbon dioxide concentration in the atmosphere 800,000 years ago, and then in the right side it's the present day, the concentration of the CO2. And as we can see, during this almost million-year period, the concentrations have fluctuated very much. But now when we are looking the curve at the present day, we can see that it has reached, first of all, it has like taking a directly vertical movement and then reached like a record concentration during this time period. And if we compare this kind of situation to any previous known climate change in the planet Earth, we can say that this is unique. And that also makes the question, so how well do we understand and know what kind of impacts this warming actually makes? So what will actually happen? Yes, so once more, so if we consider this, what has happened during the, let's say, past 100 years or so, in the eyes of a climate history of planet Earth, it's something like rapidly we have put carbon dioxide to the atmosphere, and therefore the climate warming at the moment is quite rapid. Okay, then before we go to what actually, for example, is predicted, how the climate will change in Finland, let's see how it has changed already. So here you can see black dots connected by lines, and each one dot represents the annual average temperature of Finland since the 1900 to present day, or here it's actually 2000, or actually it is 2020. I have misspelled the 2019. It should be 2020. But so you can see how these black dots fluctuate from year to year, and that is really typical for the regions or countries in the high latitudes. So the annual variation in weather conditions is really large. But now when we are approaching the present day, or the 2020, we can see that actually this year-to-year variation is happening around a new climatological average. So this red curve, actually it is like a trend line fitted into in the middle of the dots, and we can clearly see that especially during the past 30 years or so, the warming has been quite intense. And for example, also in Finland, the years have become on average warmer than previously. But please note that when we are talking about the future climate in Finland, you have to remember that, for example, very often you will see only this red curve in the future. For example, in this curve continuing to end of the century. But remember that this year-to-year variation is still present in the future climates. So not all years are still warmer than before, but there will be also colder years and wetter years and drier years, so the variation still exists in the future. question here, but of course you can answer, somebody can answer if wants, but if we compare the present, like the previous climate conditions in Finland, let's take 30-year periods, two different 30-year periods, so 1991 to 2020, and we compare that to previous 30-year period, 1961 to 1990, and let's examine, for example, how much the winters have become shorter compared between these two different periods. So would somebody like to make a guess? So how many days maximum, for example, or for example here in the southern Finnish parts? 2 days? Any other? 4? One more guess? Well, I can give you the correct answer. It's in the southwestern parts of Finland. It's more than a month. For example, in the island of Ahvenanmaa, it's 36 days maximum. And then also for example, in the Helsinki region, it's also like several tens of days. So these kind of changes we have already observed. And now what will happen in the future, so whether this kind of change will continue as such, or will it get more intense or less intense, that is then the critical question. And one more really good picture about the annual variation. So how different years can in Finland and in where Finland is positioned in high latitudes, how large annual changes there can be. So, for example, here is one of my colleagues' picture from his backyard in Hakunila, if I recall correctly. So the left image is from 2008, and the right image on the right is 2011, but exactly from the same day, so 23rd of February. And you can see that in Finland, these kind of conditions are possible with or without the climate change. But now, when the climate has gotten warmer and will get warmer in the future, these kind of conditions that are on the left figure, they will be more probable. And the probability of the conditions on the right will get less probable. So their probability of occurrence will change. And that's what is actually climate change about. It's changes in the probabilities of occurrence of different weather conditions or climatic conditions. But for example, these kind of like cold and snowy winters, they will not disappear, but their probability will change. And then this is actually maybe the most relevant picture of the global warming. So here you can see how globally the temperature, the average annual temperature of planet Earth has changed. That is the black curve. And then continuing from year 2020, there are the predictions how the warming will continue, depending or based on how these fossil fuel or these greenhouse gas concentrations evolve. And for example, I can give the answer how the concentrations will evolve, because that depends totally on the human activities or non-activities. But what I can say is that if the emissions continue as they have continued until now, then the global warming will be something that is shown in by the red color. And for example, then we can say that at the end of this century, the planet is most probable, let's say 5 degrees warmer than in the pre-industrial times. And then this the whole red color area represents the uncertainty in the climate model predictions. But anyway, several Celsius degrees warmer the planet will be if we would consider this business as usual scenario. Then on the opposite side is the Paris Agreement emission scenario, the blue color area. So that means that if there are rapid and efficient actions in reducing the carbon dioxide emissions and other greenhouse gas emissions by human activities, then it is possible that this warming trend will stop and the planet is not that much warmer than let's say today. So, but anyway, if we look at the graphs, we can see that there is no going back, even if we would, like worldwide, achieve a totally optimal mitigation, like climate change mitigation policies and actions. Still, our children and you and my children and their children and their children's children, they will live in a much warmer planet than for example, I have been living when I was a kid. But please note that this, how large is the warming trend? That depends totally on the concentrations of greenhouse gases, and therefore there's a direct relation to the what worldwide policies and achievements that mankind will make. Then also one thing is that now the Earth is warmer than previously already, and it will get at least a little bit warmer as a minimum, or a lot warmer as you saw in the previous graph. But anyway, there are some changes which will eventually happen anyway. So for example, in some regions there will be more precipitation because temperature and moisture in the atmosphere, they have a relation, so that the warmer is the air, the more moisture can be contained in that air parcel or air package. And therefore, if the planet is warmer, that means that the cycle of water gets more intense. So there is more evaporation, and because the water is not disappearing from this planet, it precipitates down somewhere. That means that some regions are getting drier and some regions are getting more moist. And for example, in Finland, in a big picture, on annually averaging, we will get more precipitation. But the same is not, for example, in southern Europe. In Italy, Spain, there will be less precipitation, especially in the summertime, meaning that there will be drought issues. Then some impacts of the warming are actually somehow that they cannot be turned backwards in time. So, for example, the ocean levels, the sea level has been rising and it will still rise, and that cannot be turned back, although we could stop the temperature increases, because oceans are huge, like piles of or containers of energy, of warmth, so to speak, so that they will contain it for centuries from this moment on. So that means that, for example, in let's say hundreds of years timeline, the ocean levels will not start to go backwards. Then also the same is for the large ice areas. For example, in Greenland, the volumes of the ice will decrease, that will not immediately or in hundreds of years lifetime, it will not gain back it. Then about how in Finland the temperature and precipitation amounts in a climate way, looking how they are predicted in the Finnish region. So on the left there is the predicted temperature changes, it is the annual mean temperature and how it is predicted to change depending of these different greenhouse gas emission scenarios. So the red curve is the business as usual scenario, so that humankind we will continue our way of life as we have lived during the past decades. Then the green line is it's green line. That is the Paris Agreement scenario. So really efficient and quick and rapid and globally reaching emission reductions and climate change mitigation policies taking place, which means that the warming trend of the Finnish climate will eventually at the mid of this century stop, and then there is a new, let's say, new climate, stable conditions. And then on the right there is the predicted precipitation change in percentages, so how the annual mean precipitation amounts will change compared to the present climate. And we can see that actually in Finland the precipitation follows quite well how the temperature will change, accordingly will change also the precipitation. So depending on the greenhouse gas emission scenario, the annual amount of precipitation in Finland will change from a few percent to several tens of percents. So about 20% is the largest change predicted. Then to conclude, some highlights, or maybe highlight is the wrong term, that some main predicted changes that will occur in the Finnish climate. So the temperature will change in all seasons, but especially in the winter time, which I think also you have noticed in your neighborhood. Then the soil frost, because the winters are getting warmer, the soil frost will diminish basically in the southern parts of Finland, and this has especially huge impact to the forestry, for example, because typically forestry is the winter season is quite important for the forestry business. Then the wintertime precipitation amount will increase, and then in the summertime more and more we will experience this kind of like a hot periods. But in the amount of windstorms or severe winds, the climate models suggest that in the Finnish region or in the Nordic region there are not that large changes expected. So that means that, for example, we will not get more and more severe windstorms in Finland, but likely there is not big change. In the summertime, the conditions will be more and more favorable. These like several weeks, like extensive dry periods, which then end to heavy precipitation, like a short and really heavy precipitation, like a shower type of precipitation events. And also at the Baltic Sea, the sea level is rising, but because the land is also rising in the Finnish region, especially in the Bay of Bothnia, that means that actually there, for example, in the Vaasa or Pori region, actually the sea level is not rising because the land is also rising after the previous ice age. But in the, for example, in the Helsinki coastline areas, the land rising is not that large, which means that during this century it is estimated that the sea level will rise like several tens of centimeters. I think the mean estimated value is something like 30 to 40 centimeters in the mean sea level height. And it's of course not a surprise that if the winters are getting warmer, that means that, for example, the sea areas in front of Helsinki, they are less often frozen for long periods of time. But it is important to know that still in the future, for example, 20 years from now, it is possible that there is a cold and snowy and icy winter. So they will not disappear, but they will get just more and more rare. So these kind of changes have already taken place, and they will take place more and more. But how large are these changes? That is directly related to how much greenhouse gas emissions humankind will in the coming years put into the atmosphere. Then I took some questions from, you have a really extensive list of questions. I cannot answer them all in this meeting or in the seminar, but I took some relevant questions which are anyway often asked. So, for example, the Gulf Stream, Golfvirta. So in the news you might have read that, and you might have first of all learned at the school that it is really important current in the ocean for the Nordic region. So our climate is, because of this warm Gulf Stream, our climate in Finland is about 10 degrees warmer than, for example, in the same latitude in Siberia or somewhere else. And basically it is assumed that if, so when the climate is getting warmer, that should actually make this Gulf Stream a bit weaker. So not that much warm water is coming from the Caribbean region to the ice ocean regions, and that would mean that our climate would actually get colder, and that is possible. And it's actually possible that it will happen, but the impacts of that kind of change to the Finnish climate is, we are talking about, let's say, few hundred years of changes. And if we compare it to the changes of what is happening now because of these fossil fuel burning and these greenhouse gas emissions, we can then say that, okay, maybe we should not firstly think of these Gulf Stream impacts, but whether to try to focus on this greenhouse gas related warming. Then this is often asked, so Finland is a small country, we have a few millions of citizens here, so why should we do everything, like all kinds of actions, climate actions, to support the climate change mitigation? Because, for example, compared to China, USA, Germany and these kind of big industrial countries, they are giving a lot of these emissions, so maybe they should first do something. And that's a good, relevant question. But actually, if we make an average of the Finnish emissions per citizen, actually the emissions of Finland are actually, I think, in the top 5 in Europe. And that is because we are living here in the north. We have a lot of traffic. We need heating during the winter season. We have a lot of industry, especially heavy energy utilizing industry like metal industry and so on. So we consume a lot of energy. And for now, most of that energy have been taken from oil and coal and this kind of thing, gas. Then the other thing is that, and this comment actually I received from in one seminar, this kind of seminar. So from the audience, there was a comment that yes, okay, so China is a big, a country giving a lot of emissions, but why there are so many, for example, industrial facilities and factories there? Because they are producing different kinds of stuff, for example, to the Finnish consumers. So therefore, and that actually made me think, so we are also involved and part of the Chinese industry somehow, not directly but indirectly, and so maybe that's also important to think of. And then this is also quite often commented thing for example, our institute. So now, for example, there are minus degrees outside, a bit of snow, and then quite often there is a comment from some citizen that, okay, you said that the Finnish climate should get warmer, but now it's cold, and so how is that possible? So I think the climate change has been reversed, but that's not the case. So like I mentioned several times, the cold situations in Finland, they will not go away, but their probability just will get lower. And therefore it's important to understand these differences in weather, in a certain day, during few days, and then in the climate. So climate is something different. And so that was my presentation, and thank you for your interest and time, and would be happy to receive some questions, but I think we agreed that maybe we will skip it from this seminar. So thank you.
Kiitos paljon Antti Mäkelä mielenkiintoisesta esityksestä. Uskon, että me kaikki kuulijat opimme paljon.
Thank you, Antti Mäkelä and the audience. Let's have a round of applause for our guest, Antti Mäkelä, both in the classrooms and here in the central hall.
Kaikille oikein hyvää joululomaa.
Merry Christmas and happy holidays, everyone.